All right, so with this addition of these alkyne reactions, we've learned a really powerful reaction, and that's this carbon-carbon bond formation. And so we've only learned how to do this one way. And that's through these terminal alkynes, right? So we have some sort of terminal alkyne. We add some strong base to deprotonate this to form our acetylide ion. And then to this, we can add some of our alkyl halide. Remember that these alkyl halides have to be methyl or primary. And this will undergo an SN2 reaction to form our carbon-carbon bond. Right, so here we form this carbon-carbon bond. And so this will be a really powerful reaction. And naturally, if you see an addition of carbons, you must go through this mechanism in terms of this course. So for example, if you see this component and then you want to do some kind of synthesis, some kind of multi-step synthesis to expand this alkyl chain, right here we have this kind of methyl, and now we're turning it into a propyl. And so what we've done here, if we count the carbons, there's one carbon outside of the cyclohexane, and now there are 3. So we've added 2 carbons. And the only way we've learned how to do that is through this acetylide ion, right? So since we added 2 carbons, it must just be this acetylide, right? Carbon number 1 and then number 2. And so we already have our alkyl halide, so we can just go ahead, add our acetylide ion or acetylene and a base as well to form this complex right here. And now we're thinking 1, 2, 3 carbons. We've got all 3 of our carbons there. And then finally, how do we go from alkyne to alkane? That's that reduction. And so we just use hydrogen and some sort of catalyst to get to our end result. So you can see that this carbon-carbon bond formation is quite powerful. Of course, we have learned a way to go the opposite way as well. So what if your products have less carbons? Right, that's also something that could happen. In this case, the only way we learn how to go through less carbons is through oxidative cleavage of our alkenes or alkynes. So remember, we have this alkene here. It's 1, 2, 3 carbons long. And in one step, we could cleave this and make this a 2 carbon long chain, right? So in this case, we end up with an aldehyde. So that's with our ozone, O3. And in this case, a reducing agent such as zinc. You could also go all the way to a carboxylic acid instead, 1, 2, 3 carbons. If we add O3 and then peroxide, we're going to cleave this bond right here. And so we'll be left with a carboxylic acid that has 1, 2 carbons in it. And then we have 1 carbon left over. So you form carbon dioxide there. You can use this ozonolysis or you can use the permanganate. Under acidic conditions, they'll both do the same reaction here. And of course, we can do this with alkynes as well. So again, we have 1, 2, 3 carbons. If you see a product that has less than 3 carbons, you know that you underwent some kind of oxidative cleavage, right? Here we only have 1, 2 carbons. And so we must have oxidatively cleave this, right? In this case, we don't need a reducing or oxidizing agent after, and we can just cleave this bond right here. So if you see more carbons, you did some kind of alkyne SN2 reaction. If you see less carbons, you did some kind of oxidative cleavage.